Hello everyone. Welcome to one more session on multisim software. My name is Dr. P. Shyam Sundar, Associate Professor, Department of ECE, KL University. And today I'll be explaining about the next experiment, opto isolator. This opto isolator I'll be giving in three parts. In the first part, I will be explaining the operation of this circuit. In the second part, I will be showing you the simulation output. And in the third part, I will be showing you the practical output. So let us see how this circuit functions. Opto isolator. The thing is, this circuit has two parts which are isolated to each other, which communicate with each other by optical signal. If you observe here, this is MCT2E, which is the opto isolator or optocoupler, in other words, we say, where it consists of a LED and a phototransistor. This LED emits the photons and the phototransistor receives the photons, based on which the output signal appears. Let us see the operation in detail. Let us split this circuit into two components. The first part is the transistor switch part, which you see here. This entire part, sorry, this entire part is the transistor switch part. This is transistor switch part. So uh, the component values are chosen as RB is 47 kilo ohms, R1 100 kilo ohms, and RC is 220 ohms. Here we are taking this as 220 ohms for a purpose. When this resistance value is to 0.2k, the current which is flowing through the output or the load, we can call this as a load now, through the load will be decreased. As the resistance increases, current decreases. So the current which the LED receives is not sufficient to drive the LED into on state. That is the reason why the resistance value here at collector is reduced. Same way on the other end, the resistor value is reduced for the same reason. Okay, I am connecting a function generator which provides a frequency of 1 Hz. Why 1 Hz means human eye cannot see. If at all you apply 1 kilohertz, and if you want to see the LED action turning on and off, the switching action of this LED cannot be observed by our naked eye. So when you give the frequency of 1 Hz, the time duration between this on and off pulses will be 1 second, because of which your naked eye can see the on and off or switching of this LED. For that purpose, the frequency is chosen as 1 Hz and amplitude is 5 volts peak to peak as in transistor switch. When you apply this signal, the transistor acts as a switch and the output will be a square wave which oscillates between 0 and 5 volts. 0 and 5 volts because VCC is 5 volts. Now this LED turns on at the voltage of 3.5 to 5 volts. So as the current flows through this, when the LED receives more current, across which the voltage will be greater than 3.5, then this LED will be turned on. Since it is a switching action, it oscillates between 0 and 5 volts. Whenever the output is VC is at or 0, the LED will be turned off, and whenever the output is VCC 5 volts, the LED will be turned on. So with the same frequency, the switching action happens here. LED will be turning on and off simultaneously. Now this is connected to the opto isolator through a 1.5 kilo ohm resistance. This opto isolate this opto isolator is a 6-pin IC. The pin out configuration is given such that pin number 1 is the anode of the LED within the optoisolator, and pin number 2 is cathode of the LED which is inside the optoisolator. Pin number 3 will be no connection, pin number 4 will be emitter, 5 will be collector, and 6 will be base. Usually this base is not connected to anywhere. The signal which is the photons which are emitted by this LED is received at the base of this transistor. So there is no connection for pin number 6. So on the whole we have 4 active connections, 1 and 2 between which an LED is there, 4 and 5 between which a transistor is there. Right. Now based on this switching action, here this LED will transmit the pulses, and based on this transmission of pulses, this transistor will turn on and off, based on which your output LED will be turning on and off. When you observe here, between the input signal and the output, as in transistor as a switch, you have seen that the input signal and the signal at the collector will have 180 degrees phase shift. So this input signal and the LED blinking will be opposite. Whenever the input signal is high, LED will be off. Whenever input signal is low, LED will be on. Now since this is passed through a transistor again which is in CE configuration, this LED and this LED are 180 degrees out of phase. That means when this LED is on, this will be off. When LED 1 is off, LED 2 is on. In other words, the function signal which you apply in the function generator and the LED2 signal will be same. Of course, that is 5 volts peak to peak signal, whereas here this signal will be in between 0 and VCC. So this is the operation of optoisolator. You have to see that both the circuits are isolated to each other. The supply as well as ground of both the circuits will be different. The ground of this entire first circuit is considered here, and the ground of the second circuit is considered here. Just draw an imaginary line in between the MCT2E. One part, the circuit which is on one side will be one part of the circuit which is on the other side of the imaginary line will be the second part of the circuit. Since this isolates these two parts of the circuit, and even when isolated, the circuit gives the output of switching of this transistor and that switching action can be observed as the LED blinking. So this is opto-isolator experiment. Thank you. In next session I'll be explaining the simulation part of